Hello everyone, Assalamu alaikum. Welcome back. In this video, I want to briefly just outline a little bit about deep learning hardware and software landscape. So, regarding hardware for deep learning, what has happened in this area, there's a lot of research going on, but essentially, most of it is still, or you can say, most of deep learning is still done using these GPUs. So Nvidia is advancing the GPUs every year. There's a new model every year, actually a set of models. So most of people still use GPUs for deep learning. However, especially if you work at Google, there are also now cloud TPUs. Now TPU stands for Tensor Processing Unit. It's kind of like a specialized version of GPUs that are better at certain tasks. I think I'm not an expert in this. I actually never use TPUs because I have my own computers, and TPUs, well, I think are restricted to Google Cloud servers. Although as a user you can rent those, but I think each TPU it's technically cheaper than a GPU, but not as powerful. The power comes from the fact that you can combine a lot of them together. Anyways, ARM is also working on machine learning processors. Also, the new MacBook I think has an ARM processor in it, which is kind of very competitive compared to GPUs, but it's more for prediction compared to training. So right now, still GPUs are the status quo. Most people are using GPUs, but again, other companies are also developing custom chips focused on deep learning, just to make deep learning more efficient. Because if you think about it, GPUs are really inspired, or they come from the gaming industry, so they were not developed with deep learning originally in mind. However, they are very good at deep learning nowadays. And Nvidia also develops chips that are especially for deep learning, not for gaming. And there's a company called GraphCore. There's also now IPU, which is an intelligence processing unit, which is especially useful for graph neural networks. So you have CPUs that are good at computing simple computations with scalar values, GPUs that are very good at working with vectors, and these IPUs are very good at working with graphs. It's also a new thing. And regarding the software landscape, I don't want to talk about it too much, but I thought it might be interesting because you may also, as a student learning now PyTorch, wonder what the other libraries are, and for example how it relates to PyTorch. So here's a nice summary from Deep Learning with PyTorch book about the history. I remember before 2015 people used Theano, and then approximately in 2015 TensorFlow came out by Google, and also lots of things have happened since then. So back then, Lasagna and Keras were high-level wrappers around Theano. So high-level wrapper means making things more convenient, because both TensorFlow and Theano were very, you can say, low-level languages. They were not very easy to use, and you could do a lot of things. They were very powerful, but you needed to write a lot of code. So Lasagna and Keras, they provided more easy access, but then also Keras extended its capabilities and also was made compatible with the TensorFlow and CNTK. CNTK was a deep learning library by Microsoft. I'm not sure if it's still around. I think it also stopped the development. Then there were other special purpose libraries like Caffe, Chainer, Dynet. Dynet I think was dynamic graphs, and Chainer was also dynamic graphs. Caffe was especially good for deployment, like mobile devices and things like that. I think it was based on C++, MXNet, and so forth. And there were many other libraries. But so what happened then in the next couple of years, a lot of people were switching to TensorFlow. So Theano stopped actually the development. So Theano was a university-based library on TensorFlow Extended. So they consumed Keras. So Keras became a part of TensorFlow. I think Keras developer started working for Google. Then they hired him, and they were more tightly integrating tens of Keras and TensorFlow. So then in TensorFlow version 2, Keras became the default API for TensorFlow, and they also added eager mode, which is similar to PyTorch. And dynamic graph. So PyTorch got this dynamic graph idea, kind of like from a chainer. That's another library here. And then TensorFlow also added it later on because it was really popular with the users of PyTorch. And then in TensorFlow 2, nowadays there's also an eager mode. I heard some people or many people at Google don't really like working with TensorFlow anymore because it's a little bit clunky. So there's also a new library called JAX, which was developed at Google. So that's independently developed from TensorFlow, and it's kind of like NumPy that can be run on GPU. Also, it also has AutoGrad and JIT capabilities. It's a relatively new library. Looks interesting. I think you can do cool things with it, but I think it's not where PyTorch is right now with all the features for deep learning. It's more like a lower level library. There are other libraries on top of it. I think it's called Flex, um, which is like a wrapper around JAX, more for deep learning. But again, on PyTorch is really, I think nowadays the most mature library that is also nice and easy to use. So most researchers really use PyTorch because it's easy to use, and I really recommend that as a beginner, especially. But also, it's just like something everyone uses nowadays, and there's nothing wrong with that. PyTorch, the history of PyTorch is that they compute this consumed cafe um, to us again, and independent project focused on mobile development and server deployment, because PyTorch was more like a research library. Now it's both, so it's good for production on mobile devices and stuff, but also still for research. It was made way more efficient over the years. Got on ONNX support, which is standard for exporting neural networks into a common format. So you can actually export PyTorch models and import them in other libraries, other deep learning libraries and stuff like that. And they actually added graph mode. So in that way, PyTorch became more similar to TensorFlow by adding this graph mode, and TensorFlow became more similar to PyTorch by adding the IGA mode. So they are both very similar nowadays. Anyways, that's just a short history of how software developed over the years.